Okay guys, here's a, damn, this is actually a notebook. I just got to write a notebook. Alright guys, so here's a video on, ignore the Android quality, because I do have an Android, so I don't. Here's a video on, oh fucking ass. I swear I had like 50 notebooks. This is one take, so I'm not redoing this shit. Okay, so boom. Okay, so boom. Here's a video on... I need to stop. I'm sorry. I apologize for that. Here's a video about... Oh, this notebook is so unused. I don't know why I didn't use this notebook. Alright. Here's a video on limit notations. So let's take a random set of numbers. Sorry. Let's take a random set of numbers. X minus 4 times x plus 6 over x minus 4 times x plus 2. Alright, so this is our equation right here. So the first thing I like to do is obviously eliminate, and let's name what we have. So if we eliminate the x minus 4 and the x minus 4, right, we eliminate those two. Now we have a whole at x equals 4, right? And so that's gonna piss me off. Alright, so our whole is at x equals 4. Right? Okay, so boom. Alright, so now, don't piss me off. Sorry, I'm looking at the picture right now. No, that's gonna go away. Okay. So, don't piss me off. Okay, so now we see our whole is at x equals 4. So now we see all we have left is x plus 6 over x plus 2, and that's our fully simplified factored form. Right there, x plus 6 over x over 2. X plus 2. Now, what we're going to do is we're going to find our 0. So our 0, since it's x plus 6, our 0 is at x equals negative 6. That's going to be our 0. And our vertical asymptote, because, yeah, our vertical asymptote is going to be x equals negative 2, because x plus 2 is at the bottom. Alright, now that we have that, one more thing I like to do, this is just me personally, so I know, like, it helps me, is to, obviously horizontal asymptote, that's helpful. So our horizontal asymptote is going to be at y equals 1, because it's the same degree. So it's just going to be a ratio of the highest degree. And then another thing that I like to do is to find my y-intercept, because that honestly just, for me, it's a really important part of graphing. And I like to graph for, when I'm making my limit notation, I like to see the graph. So our y-intercept is just, imagine these x's aren't here, because they're going to be 0 in their place. So our y-intercept is going to be 6 over 2, or y equals 3. Wow, that's amazing. It's my religion, feels so good. Okay, so boom. Alright, the next thing I like to do once I have all that data, so right now we have our data, which is whole at an x equals 4, our 0 at x equals negative 6, our vertical asymptote, or asymptote at x equals negative 2, our horizontal asymptote at y equals 1, and our y-intercept at y equals 3. Now, I'm going to graph. So I like to start with my horizontal asymptote at y equals 1. First step. horizontal asymptote. Sorry, yeah, horizontal asymptote, and then let's do our vertical asymptote at -2. 1, 2, 3, 4. Sorry, I don't know why I started counting, but that's -2. Alright, and then I like to plot my y-intercept, which is going to be at 3, and my 0, which is going to be at -6. The 0 and the y-intercept is what tells us which way the graph is going. If it tells us if it's going to be at the top left corner and top right and bottom right corner, or if it's going to be at the top right corner and bottom left corner. That's how we know what our that's how we know with our x and y intercepts. Because if we look at this graph, right, we see it has to cross at y = 3, right? Which means that there has to be there has to be a thing there. There has to be a the part of the function has to be in the top right quadrant, because that's where our y-intercept is, in the top right quadrant. And then we also were reaffirmed by the fact that our x-intercept, oops, that's not right, sorry. We're reaffirmed by the fact that our x-intercept is at -6, which is in the bottom right quadrant, or bottom left quadrant, which means that our function, the other piece, has to be in the bottom right quadrant. This right here and this would tell me where these two had to be. Because, let's say, for example, let's say it was the same, let's say it's the same function, this is just an example, same function, horizontal y = 1, vertical x = -2. But our y-intercept is at -6, and our x-intercept in would technically have to be, well, yeah, let's say that our y-intercept was at -6. That means it doesn't matter where our x-intercept is, because basically if there's an intercept, then the function can hop over the asymptote, but don't worry about that. The point is, if there's a y-intercept, if our y-intercept was at -6 instead of +6 right here, that means that we have to have this be in this part, which means that, sorry, this has to be in this part, which means that this would have to be in this part. So depending on where our y-intercept is, it flips the function. And don't worry about the x-intercept, because basically what happens when there's an x-intercept that's below the horizontal asymptote, the function just kind of dips down and grabs it. It's just, don't worry about that. But the point is that if our y-intercept was negative, then that's how it would have to be. So, now that we made our graph, which I think is very important for making the limit notation, the first thing we're going to do is we're just going to talk about the end behavior from -infinity to positive infinity. So, the limit as... sorry, no, I fucked that up. Alright, so the first thing we're going to do is write LIM. First step, LIM. Then we're going to take x, and x is going to go to -infinity. And that x -3 has to be right underneath the LIM. Right underneath. Right there. Now, after that, we're going to put f of x next to the LIM, and we're going to say it equals whatever value we're going to. So, for this one, let's see. For this one... Sorry, no, that's not what we're doing. It'll be the f of x. Sorry, we're going to do x goes to our vertical asymptote, which is -2. So what we have to do is consider from the left and from the right. So obviously we have one side here, which is the left, and one side here, which is the right. Right? So we look at it, we see that on the side with the y-intercept, we can see that we are approaching the vertical asymptote from the right, so -2, and we're going to add a plus sign above the -2. That plus sign means from the right. So we add a plus sign above the -2, And then alright, and then our f of x is going to equal, so we can see here that the f of x, as it approaches that vertical asymptote, it's going up, which means it's going to positive infinity. So that's our whole thing for limit notation for going from the right side. So this reads as the limit of f of x, the limit as x approaches -2. No, sorry. This reads as x approaches -2 from the right side, the limit of f of x is equal to infinity. This just basically means we're going to -2 for x, which is the vertical asymptote. I think this is flipped, but I'm gonna see if I can try to flip it back around. But basically, this means that we're going up. We're going up, 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 as we approach that vertical asymptote of -2. We're going up continuously, right? That's that. So next we have to see as we approach from the left. And obviously, you can kind of you don't really have to work it out for this one, because if one side is going from positive infinity, that means that the other is going to negative infinity. But for shits and giggles, we're gonna solve it out, just so that way we can have that. So as x approaches -2 from the left, which this is from the left, right? Yeah, this is from the left. As we can see, it's approaching from the left, and it's going down, 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 which means the limit is equal to negative infinity. And that's all we're going to do for that. Now, sorry, one thing about this graph is that there's a hole, right? Our hole is at x equals 4, which is about right here. So let's draw that little hole right there. I don't like how that sounds. Let's draw that hole right there. So that hole is at x equals 4. It doesn't really matter the y value all that much, because I'm not really calculating that right now. I will do a separate video about that, so I got you on that one. But basically, our hole is at x equals 4. And now we just have to do, oh, actually, well, a part of this is going to be solving for that y value. So we're going to do that, and then I'm going to do another video where I talk about solving for the y value and solving for the y value and solving for the y value of the hole and solving for the limit as we approach that hole.